Hello and welcome to the second part of my series of tutorials on the PMDG Boeing 737 NGX. I know you guys have been waiting for quite some time, so let's get started on the on the second part. Okay, so to the aft overhead, no messing around here. Just try to make this as quick as possible because the last time I attempted to make this video it ended up 40 minutes long. So without further ado. First thing we need to do is check the leading edge devices enunciator panel just by clicking the test button. Simple as that. Just make sure all the sections on the wings are operable. The second part of the flow is dependent on whether or not you were handed the aircraft off by another crew who just previously shut the aircraft down. You just need to make sure that the IRS mode selectors are in the align position or nav position. Next part is the service interphone switch, just to ensure that it's off. Reverser lights are extinguished. The EEC switches are on, and on either side the lights are extinguished. Crew oxygen pressure, just check it's in the required range, which it is here, so that's fine. Flight recorder test switch needs to be tested, so we're going to right click this and click it into the test position and then switch it back to the normal position. Normal remains off, don't worry about the off sign. In normal mode it switches on whenever it's time for it to switch on. Mark airspeed warning buttons need to be pressed, so, and stall warning test number 1 and number 2, and the proximity switch electronic unit needs to be checked. This little light here. Next part of the flow, we go and check crew oxygen system is operable. There we go, that's working. This is where we would put our present position in the FMC, but we haven't received the aircraft from a previous crew. We're starting from the ground up today, so we don't need to do that part of the flow. So we skip on to the next part of the flow, which is just setting up the aircraft lights to suit your needs. If I just put these on and just a tiny bit I say, but it's quite bright anyway. Now we're going to go to the aft overhead panel and just test the master lights test switch. Now we need to check the flight control panel. Now that I've zoomed in, you can see that the that is the off position and that's on. It looks a bit confusing unless you zoom in, so I just wanted to zoom in and confirm that to you. So we've confirmed that these are in the on position and they're guarded, both guarded. Your damper is on. Navigation panel is checked, and basically what you're looking for is that everything is on normal. Electric panel, just check that everything is normal there too. We're on auxiliary battery power and ground power rather than APU. We don't want to waste fuel. Cabin, utility, in-flight entertainment, passenger and galley switches are both on. Equipment cooling switch is in the normal position, which is up. Passenger switches, passenger signs need to be on. Window heat switches, gonna test them and then switch them on. test them, and switch them back off. And the probe heat switches need to be tested, and then switch back off. NTI switches, just check that they're working. So that's working, those are both working. Let's test the hydraulic pump switches. There we go. Voice recorder. Is tested. Pressurization indicators. Now we just need to check that these are within the in the required range. So okay, so our cabin altitude is 0 at the moment. Obviously we're on the ground. Cabin climb is also 0 because we're on the ground. Zoom back out. Cabin temperature. You just need to adjust these really. I'm not going to really change anything here. All looks fine. I don't need to do anything. Wing body overheat needs testing, so we'll test that. There we go. Next thing is the pressurization panel. We just need to set this now. So we've got our passengers in. Okay, I think we have ground air, so we're going to turn the recirc fans and left and right packs on. Ignition selector needs to go into the right position. This is where you'll go ahead, tune into the ATIS, get the ATIS, find out what runway's in use, do your takeoff calculations, put everything into the FMC as normal. So we're just going to do that quickly now. So let's say, where shall we go? Let's go to Manchester. So we're just going to put EGKK, which is where we're at right now, and we're on stand 553. Then we need to go to the route page. It's kindly copied the same ICAO code in the scratchpad for us, so we're just going to put that in there, and we're just going to put EGCC in on the right side. That's our destination. If we had a company route already saved by, for example, PFPX, or a hand-typed route that we've saved in the FMC, then we could just import that rather than having to type the whole thing in again. But right now, as the purposes of this video is for, I'm going to teach you how to do the FMC preparation. So we're going to skip the company route, and we're going to go off runway 26 left, and let's just say this is an example call sign, Speedbird 218. Then we click the legs page, and we're going to put our route in. Okay, so this is where you'd put your route in. First of all, airways go on the left hand side, and actual waypoints, VORs, NDBs, anything like that need to go on the right side. So first part of the flight plan, it would be Lambourne. I'm just kind of doing this off the top of my head. We need to, yeah, there we go. Lambourne. We need to check the position. I know it's 115.6 and it's around that coordinate, so yeah, I'm going to click that one, that's fine. November 57, Welling. Tango 420 to Trent. and then we're going to activate and execute that. And if we look at our nav display now, I'll just bring it up and go to let's say plan mode and zoom out a little. We can see where we start. We depart, direct Lambourne, and then if I go through all the waypoints, just step through the waypoints, you can see that we end up in Manchester. Let me just go back one. There we go, there's Manchester up there. That's the end of our route. What we need now is an arrival to Manchester, the standard terminal arrival route, or STAR, or STAR, and we need a SID as well, a standard instrument departure. So from our departure runway of 26 left, we'll be what am I doing? We'll be departing of 26 left, as I said, and we'll look for a Lambourne departure. I think it will be a Lambourne 1 X-ray, which is an RNAV departure. If I zoom out a little bit more now, you can see how that goes. Depart towards the west, then turn back towards the east, back up north towards Lambourne, and then we'll carry on the route towards Manchester. Lambourne is where the route ends, and then Manchester, you don't have to do this now, but typically I like to do it all on the ground before I depart, so everything's set up. So we'll be landing ILS runway 23 right at Manchester, and it's going to be a Dane 2 Alpha arrival. There are certain things you need to do to figure this out if you don't already know them. For example, charts. So that's that done. That's that part of the preparation done. So we're going to go back to the FMC properly now and continue the performance page. Let's just check how much fuel we have. We don't need 45,000 pounds of fuel, so we're going to just change that. Also, we need to change the display to display kilos, because we don't use pounds in England. There we go. Right. 900. Yeah. Right. So we're going to change the fuel amount to about 5.5 tons. Just say, yeah, about 5.5 tons. And the payload, we're just going to click a random payload. Whoops. There we go, that's set random now. So that's that done. Okay, so back to the performance initialization page. So all we need to do now is just put in our planned fuel. Then we need to double click our zero fuel weight. That will calculate our gross weight and our cruise center of gravity, which is 21.3%. Our reserves, 2.2. Cost index, we're going to climb on 0, and we're going to cruise on 28. So a little trick that pilots use is to put the cost index in as 0 on the performance initialization page, go to the climb page and put in your climb speed, so true airspeed 273 / mark decimal 481. So we're going to put that in, copy it over, execute it, and then we're going to go back to the performance initialization page and then change the cost index to 28 now, which is our cruise cost index. So what we've done now is permanently copied our target speed for the climb, which is based on cost index 0, and then when we get to cruise altitude, it will automatically go to our cost index 28 speed. If we go back to the Perfinite page again, we'll put our cruise winds up here. So it's 55 at 20 knots. That's 055 degrees at 20 knots. And our transition altitude, out of Gatwick at least, is 5,000. We go to the next page, N1 limit. This is where we go to our top cat, do our takeoff performance calculations, and copy in our data. So we're going to use takeoff 1 and climb, and we used a 36. Put that in there, and then just change that back because it moved it automatically. Takeoff page, flap 5. Double click CG. That's our trim for takeoff, 4.92. That's when we trim the aircraft. So what we're going to do is take the trim. It's 4.92, so it's just under 5, and just trim. So it's just under 5. There we go. That's about 4.92. Now we need to put our V speeds in. So we can just click each one. If you don't want to, you don't have to, but it's best to fill in this page. This will delete your calculations though, your takeoff speeds, but doesn't really matter. You can just click them again. Okay, this is for any sort of like acceleration height. You know, if you have certain procedures to take off out of an airport, you need to be at a certain altitude before you have your thrust reduction procedure or noise abatement. Acceleration height reduction and engine out acceleration height. That's basically in the event of an engine failure. Runway wind. This is where it will delete our current speeds. So I'm just going to put wind calm. Okay, so we'll just copy the speeds in again. That's all. Now that's more or less the FMC procedure. We can put our arrival transition level in of 50, or you could just do it in the cruise. I prefer to do it on the ground, as I said before. So onto the flows again now, and we go to the EFIS panel. So I'm just going to bring this on along to the left a little, and we need to set this for our personal use, and according to the flight data we need to take into consideration for the departure or the general course of the flight. So I don't really need to do much to this. All I need is HPA, hectopascals, because we're not flying in America or anywhere else that uses inches mercury. I'm going to switch this back to map mode and put traffic range rings on. So whenever we have traffic in our vicinity in the air, the TCAS will show it on the display and we can get range. So this is 2.5, this is 1.25, this is 5, etc, etc, and if I zoom out then the ranges change. That's 2.5, that's 5, that's 7.5, that's 10, etc, etc. Okay, so I'm going to zoom back in again. MCP, we're going to set the MCP. So For our departure, we need runway heading. Even though we'll be doing LNAV just shortly after departure, but it's common practice to set your departure heading. Initial altitude is 4,000 feet on the SID. We can see that in the FMC here. 4,000 feet or below. It should actually say on the departure chart is your V speed. So we're going to set our V2 speed. You need to put your V2 speed here. Some airlines use V2 plus 10 knots for certain reasons. Some use V2 plus nothing. Some use V2 plus 15 or 20. I think 20 is the maximum. But we're going to take off with just V1 speed. Flight director on the side who's commanding the aircraft first. So if captain has control, you switch the captain's flight director on first, and then the first officer. If it's vice versa, then you would switch that off and switch it back on. So master goes to the flight director of the first officer. And again, if you want to reclaim control and you're the captain, then switch the flight director of the first officer side off, and then you will relinquish control. Some airlines use LNAV and VNAV before they depart, some don't. I'm going to, so I'm going to put those on, and we'll leave the auto throttle for departure from the gate. Autopilot indicator lights are normal. Autopilot indicator lights are normal. Display select panels are normal. Basically, if you switch these left and right, you can switch the displays round. Say something goes wrong with one screen, or company procedures require you to do so for any weird reason or whatnot, you can actually switch over different displays. This is the lower display unit. If I switch that on, for example, and switch it, it will put the copy of the nav display down there, or it will switch that off and you'll get the engine down there, engine display down there, whichever way round. Flight instruments, flight director, you would change your I'm just going to press B, set and check your ND. Then next thing we need to do is check the standby attitude indicator, standby altimeter, your RMI or radio magnetic indicator, N1 setting knob to auto, and speed reference selector to auto. The auto brake switch should be on RTO. The fuel flow switch should be reset. Now you need to check your engine instruments, engine oil and quantity or hydraulics, fuel quantity indicators. Then we move to the throttle quadrant, and we just need to make sure that the speed brake is in the down detent and the thrust levers are down also, so just move it up and down if you like, just to make sure. Stabilizer trim is set as we did before from the FMC here with the 4.92. Start levers are cut off. Yep, those are cut off. Stabilizer and autopilot cutout trim switches. Test. If I zoom in a bit here. fire bottle squibs test. Left and right. Then we go down to the radio panel, cargo fire detection system, and test that. Forward and aft, and cancel that, and then down to the HDS panel and select whatever you like. Just set it to your needs. Now we set the transponder. So we don't have any ATC, we're just going to squawk 2000. Aileron and rudder trim is centered, and we can see that here on the on this tape. Now we need to check that the stabilizer override switch is on normal. That's on normal, that's fine. Then we need to check the GPWS. We can do that better from the first officer view. And we're just going to click the test button.
Glide slope. Pull up. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up.
And that's tested. And check the displays. And the pull up annunciation on both displays, and it will all extinguish itself eventually. So we now have the aircraft in a state where we can request pushback, you know, start the APU, etc., and get on our way. Thanks for watching this second video. I know it's been a long time, and don't forget to subscribe, and happy landings.